Good morning to all the participants for this FDP. Today is the last day of the FDP, and this is the first session of the last day of the FDP. We are having our eminent speaker, Dr. Ravishankar, Dudhe, with us. I request Professor Swati Dixit to introduce our eminent speaker of the session.
Thank you, sir. Uh, Good morning, all. Good morning, sir.
Very good morning.
I have pleasure in introducing our today's expert of first session, Dr. Ravishankar Dudhe. Dr. Ravishankar Dudhe is Associate Professor at the School of Engineering and IT at Manipal Academy of Higher Education, Dubai. He has completed his BE in Electronics from Kits Ramtek Nagpur University in 1992 and done his MTech in Microelectronics from IIT Bombay in 1999. He has completed his PhD in Microelectronics at IIT Bombay in 2011. He has worked in PCS Mumbai as a senior software engineer from August 2000 to June 2001. He has published several research papers in national and international journals. He has also published books on analog electronics 2, discrete electronic circuits, electronic devices and circuits, basic electrical engineering, satellite communication, and organic field effect transistor based electronics noise platform for explosive detection. Dr. Ravishankar Dudhe has won the external funding project Automated External Defibrillator 25,000 from Expoliv under University Innovation Program in April 2018. Also, he is recipient of internal research grant in 2017-18 and 2014-15 from Research and Development Program Manipal Academy of Higher Education, Dubai. He won Excellent Paper Award at International Conference on Innovative Research in Science, Technology and Management, Singapore in September 2017. He won Teaching Excellence Award in academic year 2014-15 at Manipal University, Dubai. So now with this, I request sir to start with his expert session on MEMS for explosive detection. Over to you, sir.
Thank you, madam, for a nice introduction.
Thank you, sir.
Good morning, all of you. I'll share my screen. I hope my screen is visible to all of you.
Yes, sir, it is visible, perfectly visible.
Okay, good. So, good morning, all of you. You are having a dose of MEMS from last 4 days. All of you are very enthusiastically attending this. My session will be slightly, which is not going to give a overdose of anything, but also taking you through some of the good practices in MEMS for various activities like explosive detection is my target. But always what I do, we will start with a warm-up. So how my talk will be, there will be a warm-up session for all of us, followed by them. Slowly I'll introduce what is explosive and what are the characteristics of the explosive which are needed for detecting, because many of us we do not know also. Some slowly then we'll introduce what is MEMS, a very brief of that. Then we'll see how this various detecting techniques are there in detecting the explosive through MEMS and other. Then small my work of my PhD which I done in the IIT Bombay, which is related with the explosive detection, will add in that. Then we'll see that how it can be taken as a project for all of you or any one of you want to do any research in this part. So at the basic part of that, and I'll conclude with letting you know where this technology or this MEMS in explosive detection or any other such things are in use. So all of you ready for the warm up? Yes, it is. I assume you are not allowed to unmute your mic, but if you are allowed to unmute your mic at anytime, you can unmute and you can respond. You can ask the question, no problem, whichever way it is. Okay. So, how many of you are feeling very good during pandemic situation? Kiran sir, is it interactive for some time in the beginning?
Yes, you can have interaction, no problem, sir.
Yeah, in 1 or 2 minutes. Okay, in the beginning they can have, right? If they want to
Yes, sir.
respond, if
Yes, sir.
otherwise
Yes, sir.
otherwise I will be doing that. Okay. So uh, how many of you are feeling good in pandemic situation right now we are going through? Is there anybody who is feeling very good or very different?
राहुल
Anybody can.
राहुल फक्त माझं एक काम कर, मी एकच प्रिंट फक्त मला पाठवून दे. मी एक SP सुधाकर माळे म्हणून मी आता तुला एक मेल पाठवले.
Okay, good.
बरं तिथे एक काम ऐक बरं, गाड्या सांगी आपलं बिडकर सरांच्याकडनं घ्या मला प्रिंट, आणि मी काय आपण बिडकरला पण प्रिंट त्याला मागितलं.
There is one reply from Professor Miriala.
मी माझ्या मी कलुरकरची
Not happy with COVID situation.
एक काम कर, तू गाडीकडे फोन दे.
Hello.
Okay, so we'll
Professor Vishnu, please mute your mic. Professor Vishnu.
Yeah.
There
okay.
is
So
one response from the Miriala Veer Badra Rao that not happy with COVID situation.
so it's okay. Now I will take you through. No worry, no worry. I will take you through. So first I'm telling you a warm-up session which is called sustainable practice, and I see how I'm defining pandemic. Pandemic basically is a very painful for all of us. It feels like, but at the same time it has brought so many opportunities, like otherwise probably we will not be discussing on this platform. And then thankful to Kiran sir and his team for arranging such a beautiful FDP and having interaction all over across the globe. People are joining and interacting with this. So when I'm talking about pandemic, the definition itself, very first thing, when I'm talking about pandemic and I'm saying sustainable, question comes in our mind. Huh? Sustainable? And that to pandemic. Can we think about so good thing in the pandemic situation? Can we use the solar energy and the MEMS combination to make my life very green? Can I make such thing where I feel like, oh, we use up the renewable energy and I am really close to the nature? Everything is a question mark. Is it really good? Is it really effective? The moment it comes in your mind, the course answer comes in your mind. No, I doubt it is like that. Okay. In fact, what our mind says, sorry, it is more pain because I'm not allowed to go. I'm not in a circle where I used to work. I'm not able to interact with people. I'm inside the wall. This all negative things in our mind. Okay. So no problem. When the pain comes to your mind, what is the thing we need to do? The moment the no comes in your mind, we have to think about, it is called new opportunities. So every time whenever no strikes the mind, yes, somewhere new opportunities waiting for us. So we have to look into positive aspect of that. When we are talking about the pain during this pandemic, this pain, so our mind always will be having the feeling, some negative feeling, some pain I'm going through. I don't want actually it to sit on my head. Yes, but what happened because of the situations we are in, the situation like with where many good things may be not happening, though if many of us trying to overcome that and also successful in that. Why I'm saying successful? When you are sitting here and listening to this and doing this FDP, of course we are able to get through this using the time effectively. So what I'm saying, when the pain is there, no issue, use the pain and the brain. So when the pain is there, use the brain. What to be done? Very simple thing. The pain can be redefined. Just remove I from there. So just come out I. What is I? You, me, everybody. Every individual is I. And when every individual comes out to do something better, you can see the COVID itself is defined like that. I have redefined the COVID. COVID is defined, can be defined as, come on, value of I is in demand. So value of I, we have to see how I can improve myself, how I can make more better myself. So what is I for us? I, since we are from the academics, either the student or the teacher or the any academician, any role, this I is for us is academician role. So what are the different synonyms of academician? It can be an academic person, a scholar, a schoolman. It can be a genius. It can be a lecturer. It can be a student. It can be a professor. Anybody and everybody. But what happens when I comes, when I am learned person, when I know certain things, and somebody try to teach me? Very important thing. This comes into picture. What is called? This is called academic ego. Academic ego, what it makes everything blurred. Everybody is trying to talk about any important thing. We are not open to take those ideas because of many other reasons. So that is slowly called academic ego. So if you really want to progress, if you really want to do something, and that's why I'm calling this a warm session, we should be as innocent as this academician. If that innocency you will bring in, learning always will be enjoyable. Otherwise it will be always attached with the ego, and our learning will be limited. Will not be able to get through what are the exact thing we are supposed to get it. So I request all of us, whenever we are in this mode, we keep our academic ego separate, keep it out separately. But yes, as I said, during this pandemic situation, I'm trying to redefine pandemic, and which you already defined. I'm just putting in from words. So here, every individual as an academician is playing the important role. And why not we redefine the pandemic then? Okay. So pandemic can be redefined. You take the pen in your hand and start working on academics. And right now what you are doing is that great thing. Okay, you are doing what you have done out of your busy schedule, out of this thing, you are here together to learn something. Means you have taken the pen in your hand and you are properly learning. But learning should not stop here. If you stop here, then this pandemic will sit on our head. So give wings to your learning. Take your pen, start working on something, start writing a review paper, start writing some of the research ideas in your diary somewhere, something. Or you can use your e-media, you can use your laptop and write anything you can use. So use the pen. Pen can be a different way you can use the academics, what you have, explore it, and then you can redefine pandemic. And this is so-called corona will be like a bright future for you. It will bring a bright future for you. So this is what I say. If you are good, positive, you continue with the sustainable practices, which some of you might be doing it. So you can make a way through a stormy situation, and there will be at the end, you will find a very light waiting for you, a brighter light waiting for you, which is called hope. Okay. So hope basically is the only way which we can think positively. And for your thing, I have redefined the hope. Actually, I am not able to show that one. I redefined the hope. Hope basically I have defined as happiness like the ocean. I repeat, happiness like the ocean remains permanently on the earth. So I hope for that. That is what hope redefined. So what we do when we start learning the new things, or we are learning the new thing in different way. All the time you must remember, to become successful, what we need to do, we need to do the existing thing, but differently. And those who learn that one, you need not do a very high level thing to do the innovation or something. The existing thing, if you start understanding them, and for that, of course, new researchers first understand that they should have a very good practice of reading review, literature review. A good literature review always make you a very good. And therefore the hope, as I said, happiness like the ocean permanently remains on the earth. And that is what our hope. And this is our warm up. So we know sustainable practice always we can get through this kind of situation. So we can redefine the pandemic by taking the pen and working with the academics which we have. So that's the warm-up session. Let us move ahead with a direct jump on what exactly we are sitting today. Okay, so MEMS. MEMS, all of you know what is MEMS, but I don't call MEMS like that, because MEMS everybody know. 4 days you were listening to MEMS, MEMS and MEMS, and everybody know. But my definition of MEMS is my engineering, my solution. So as I started with I, earlier I used to start with the V, just opposite of the ME, I just used to call WE together. But this pandemic situation where social distancing, you have to maintain, so individual role has come into picture and it becomes a very dominant. So therefore I call my engineering, my solutions. So unless until I put myself in engineering practices through any of the thing, it's not necessary that MEMS based application, it's not necessary anything. Whichever engineering practices you want to get yourself involved in, you can come up with your own solutions. Okay, so when MEMS to be redefined, it can be also done in various ways. MEMS also can be defined as it. All of you know the definition. I am not going to use that word because that is already known to the world. What we need to redefine by our way of doing it. You can always also say modern engineering. M can stand for the modern engineering, and another M can stand for many solutions. So if you apply the modern engineering, you can get many solutions. Whatever problems are around us can be resolved using your modern engineering practices. In one of them is this. Really, again, I say such kind of FDPs when we are attending, attendance is not important. Important is how effectively we take this ahead, how we remain connected with the people. We listen to our it's a very good thing where many people can come to know each other. They are in a group, they can communicate, they can continue, they can do the combined research, everything. So therefore the my engineering, my solution can be converted into our engineering, our solution. Okay, so that's the basic definition according to me for the MEMS. So let us say MEMS when we're talking about the explosive detection. So explosive detection can be done in various ways. A bulk explosive detection and the trace. Trace means very small thing. And there are existing pattern things like bulk. You know how these are detected. We know when we are going through airport, anything are there, or any VIP places, the bulk such things are there. While the trace detection is done through some of the mechanism where we'll see most of the MEMS will come into picture in the trace detection part. And the cannies, they are still the best. But this is all just the introduction. What is explosive detection we are looking at. So when we are looking at the overview of explosive detection, we should know basically nobody will let explosive coming out and telling, hey, I am here, you come and detect me and catch me. Of course, no. What is basically, they will be hidden. They will be put in such a place you'll not be able to see. Then you may have a very small particle somewhere, somebody is carrying something. Let us say this lady here, she is carrying something. So our challenge is we have to go through some chemical approach, chemistry. We always should remember chemistry is the mother of every invention, and we should not forget the physics is the father. So once you know physics, the working principle, then you develop something from that. And for developing, for sensing, for identifying, you should know chemistry. So we cannot leave that chemistry and physics. I will tell you, when I was doing my PhD from IIT Bombay, I was given 2 choices. The choices were among explosive detection, or you can have something for cardiac related, this thing, cardiac related, heart related. And I was given 48 hours to think and come up with. I was very fortunate to have my guide as Dr. Ram Gopal Rao, who is now IIT Delhi director. Very genuine person, very down to earth, but very useful to all their students. So where in the 10 minutes discussion, you'll get so many ideas. But anyway, so choice was given 48 hours. I had to choose one of them. I went with, of course, with the cardiac one. But next day only I went. But when next day I went, he said, Ravishankar, sorry, that topic is taken by somebody else. I have to give because of some limitation. So for me, left out was explosive detection are the choice. Then I said, okay, sir, no problem. When I started looking at lot of chemistry involved in that, without that I cannot go. So I went them, sir, chemistry I don't like from my childhood. He said, no worry. It's the chemistry of 8 and 10 standard. See how to motivate. Chemistry of 8 and 10 standard only you'll be required. And okay, go ahead. And then my journey I'll tell you in brief in 5 minutes afterward. But here, when we are talking about the particles of this and the trace of this explosives, it is very low, very low. You can see nanogram per ppb. Ppb is called parts per billion, and even it is ppt now, parts per trillion. So you cannot have so that very easily. It can be in the solid form particles or it can be in the vapor phase, and which is in ppm, parts per million, ppb, parts per billion, or even ppt, parts per trillion. So we have to understand how we can explicitly identify this composition, and therefore I said some part of the chemistry don't have to worry about. We are not from the chemistry background, but always the research will be interdisciplinary. So some of you can join with that, or you can get some basic idea from the already literature to get basic, which I got through, because explosive is a topic where it's not very easily understood, digestible, because we have never learned about that part of the detail. Okay, so here when we are talking about the trace detection, what are we finding? What we are trying to find? Yes, we are trying to find 1 to 100 nanogram of residue somewhere which is hidden, which could be on the concealment of the bomb, and then you are sitting on that and you are trying to see. It can be on the latches where the person went through that. It can be on the handles, it can be on the bag, it can be on the cargo, it can be on the vehicle, it can be on my whole cloth, anywhere. It can be on the interior surface, it can be on the exterior surface, anywhere. But our challenge is we have to get through that one. Okay, so where does the stress come? Explosive means where? So what happened? Let us say I am a I don't want to use the word terrorist, but yes, and I want to do some mischievous thing. So what I'll do? I'll keep my explosive at such a place which is concealed, and the concealed one will have a very rare chance to know also. So what happened when I am doing this thing or some person is doing that? There could be a contact with the bulk explosive. There could be some trace of that is there. There can be a fingerprints. There can be any contaminated hand gloves or something like that. So that kind of small thing we have to look at when the person has done. Those stress might have left there, or some vapors in parts per trillion coming out. That we need to understand. So you can understand the challenge is very big in explosive detection. Okay, so there are some compounds. Don't get afraid of. No need to worry about any compounds in all. I'm just trying to tell you these are all explosive kind of thing. Okay, let us say RDX, let us say TNT, landmine. But if you look at all of them, what is common? Common here is NO2, nitro compounds. So there are chemical things we understand. Oh, sir, can we do look at that somewhere, some mechanism or some methods by which we can identify or we can detect nitro compound, and we can detect only nitro compound. That is very important. Detecting and only detecting, which I'll come in the later side, which is called sensitivity and selectivity. Very important. But no need to look at the formula and get scared about the formula. But I'm just telling about these are the nitro compounds which gives us some direction. If you proceed with that, probably we'll be able to identify some, and then I'll be taking through that some of the such methods or something. But don't worry, it is not one which is everybody to do, but we should know the process through. Okay, so when I'm talking about this contaminated thing or this RDX and TNT, all explosive, see the concentration. We should know how much concentration at the room temperature available to if you want to do perform the experiment. So you can see here very low concentration. RDX is in very low concentration, 1 ppt or something at 25 degrees centigrade. Okay, 1 ppt, 1 parts per trillion. So low, less the concentration. Slightly higher is the TNT, PETN. So people, this of destructive mind, they always try to make technology very advanced. Their money paid to them is very heavy. So what we are doing, they are 2 steps ahead of us. But that gives chance to us to work on our technology to make more refined, more this useful to society and all. But you can see the concentration is very low. So we are supposed to work on very, very low concentration to get this thing and detect this thing. So for such thing, what we have to do? When you look at that one, we have to understand, we should think about something called trace detection. And there also, when we are looking at so small value, you can look at it's a nano level. What is that compound somewhere on the my let us say my code, there is a something like that. So when you do the SCM of that, you may find some traces there, you may, oh, but how to, that is the imaging and all, but how to check it, how to identify it, how to detect it. And not only the detecting, it should be correct detection. Okay, how I can do that one? Look at that one. What we have to do, we have to do 3 steps. Collect, we have to understand something, a process called pre-concentration. Then we should know how to do separating that. Already we are collected, because collection will not be only of the nitro or the explosive vapors or explosive stress. It can be a combination of many. We have to separate it, and then we should do some mechanism to detect, which I'll be telling in that. So there is a separate thing we should know between particle and vapor sampling. Particle sampling, most of the thing, when some particles somewhere there, we can have very easy way to check that one. But when it comes to the vapor sampling, we have to be very careful, because in the air, so much air is there around, but particles will be in PPT, parts per trillion. So challenges are there. So this 3-step detection is like that. It goes. Okay, it is stress versus vapor which we are talking about. So it is a trace which cannot be detected very easily, because it is a picture, or which we can do image analysis something. But what we are trying to do is our detection will be through when it is converted into vapor, and then vapors can be detected. So trace to vapor conversion, how we do? We call something called pre-concentrator. Okay, so what pre-concentrator is basically, let us say you are in the airport, and the airport have the threat, like any time a bomb or any such thing can be there. So can we have any time, every time that go and check that where the bomb there and other this thing is? Cannot be. So what we do, we implant pre-concentrator at various places at some point. Okay, so what it does is samples the air every time you want, how good it is and how strong sensor you want to make. So it could be every 30 seconds we can sample there, it could be every 3 minutes you sample there, whatever is there. So we go on sampling that, and out of that we have some pre-concentrator is receptor. What it will do, it will take the explosive content from there, whatever is there, nitro compound, as I say, NO2 compounds, and they are trapped there. Of course, when they are trapped in that, there are certain NO2 which are not explosive. You know, our nail polish, our boot polish also have the nitro compounds. They are also trapped. Okay, no problem, because they are a nitro compound with this it may not be. So that is called pre-concentrator. So you are collecting sample, and you are just keeping which are suspicious molecule that will be stored there, and rest will be again thrown out. So you just go on doing that for sampling part, and then you connect that one. That is called pre-concentrator. Then step 2 is the pre-concentrator is heated, because what we want to release the trapped molecule. Otherwise, how will you sense them? So you have to release them. So that is the second step of the pre-concentrator. You are heating, you can see here. Okay, so it's a conversion from physical to chemical. First you got the trace residue, then you converted physical to chemical, and then you have sensors, and there our design comes into picture. So you have NOx, any NOx, I say NO2 is for us. So any sensor which you have to design, and here that MEMS base or any other explosive detector will be there. So this is a 3-step, converting your stress into vapors. So now I can start sensing. Otherwise, stress, I can go and smell. Oh, I cannot. But if the vapor comes, I can do that one. Okay, so that is the concept used. So there are 2 ways. Particle sampling, I will not go into much detail of that, but it's not needed, because we know particle sampling, how some particle which remains on the surface, that we want to sample it, check it, and see. I can do. There are mechanism already available for this kind of trace detection, in which the sample, it can be collected from any of the medium, dry medium, wet medium. If it is dry medium, they have some heater inside that will heat it, that will evaporate, and then whatever comes out that. So there is a particle sampling mechanism in the explosive detection, and there is a vapor sampling also. This kind of handheld devices are there, which are what they are made up of and all. That is what our things will be going into, and we'll be learning that also. I mean, understanding that learning means we cannot become master in a day about anything, but we can get the knowledge, and then you can explore to make it useful for us. So there are vapor tracers already available. What it does here in this space, again, sample method is used. Very important is efficiency of collection. As I told, if around you there are so many particles, but if you are not able to efficiently collect it, you are failing. But never afraid about the fail. I always tell my students and everybody, when I go to first day in my class, new students, I ask them, how many of you want to fail? They will laugh. We are here not to fail. We are here to pass. We are here to get through. But my question will be always, again I ask, how many of you want to fail? Rarely one or two hands will be up. Yes, though the hands up, I'll be happy. Otherwise, I'm always happy, because happiness should not be a dependent factor. People will not allow you to be happy. So when I talk about fail, yes, I'm talking about Dr. APJ Abdul Kalam's definition of fail. Many of you might be knowing it is called first attempt in learning. Again, every word I get across, I try to redefine the word, try to use, and therefore I am really passionately follow Dr. APJ Abdul Kalam in this mission, what he has done and what he has shown the path. So fail is, yes, you don't in research, very important thing is we should not afraid of failing. In fact, we should think of failing multiple times. So I will understand these are not the thing to be done, and what are the remaining thing I can do, or I can suggest, and I can make a case study for new researchers or researchers in that field new, though they are doing research in other field, no problem. So efficiency of collection is very important, because the high volume of sampling you have to take lot of air, and out of that only 1-2 particle per parts per trillion you are getting. Then that critically collection is very important in the vapor sampling. And then you and this is all very badly affected by environmental condition. Let us say in the rainy season, when the humidity is more, all these vapor particles will have a lot of humidity. So when you are designing any detector, we have to take care of that, because it may give the false detection. You are sitting in let us say a very movie theater, you are watching a very good movie, very hit movie, let us say. Okay, you are watching, and just assume because of the false positive, some alarm goes, and then it is for showing telling there is a possibility of bomb. What will happen? People will not wait for each other, they will start running, stampede and all. So problem is whether it was there or not there, we do not know. But because of our human nature, we'll start running over each other, we'll start pushing this, that, and so the problem which is supposed to happen because of other, it happens because of the other thing. That is false positive. So these are all things to be taken care of, and there are mechanisms. So there are some other techniques also, which is only for the picture I have put in here. For explosive detection, very heavy, but can we have such detection everywhere? Detector? Obviously no. So there is a bulk detection possible with the X-ray, with the neutron, with the electromagnetic imaging. This all we know, but we are not interested in that. We are interested in this level, trace detection, because we are talking about MEMS based thing. So there are MEMS based and electronic nose. These are the two focus area for us to discuss today. What is electronic nose useful, and what is the role of the MEMS in this electronic nose? Okay. So we'll get through this, and so what are the technology requirement for doing that? We should meet the detection specification for sensitivity and selectivity for the specified thread. Very important. If you don't understand sensitivity and selectivity in such cases, very difficult. Very low false alarm rate, as I told. Otherwise, very often that is there, and then we are panic because of that. Now in the COVID situation, what is happening now? We are panic because of the situation, not the threats which are explained or which are brought in front of us, but we are not basically afraid of the COVID, but because of the side effects which are shown to us, we are. So there are some false alarm rate should be very low. We should have very high probability of detection. It's not like when we go and then sometime only 2-3 times it detects and it doesn't. So that is called false negative, should be taken care of. Many minimal decision making by the human, that you have to take care, means it should be automated. Otherwise human may take, depending upon the mood, means it should be automated. It should be robust. It should not be very expensive, and your privacy concern should be addressed. These are the technology requirement. On that, only for a minute, I will just put this slide, and in a minute I will back. Yeah. So these are the technology requirement. So when we look at that, sir, canis, aren't they very good detectors? Yes, they are. They are very good detectors. Until now, the best detector in the world are canis. But what are the things? Why don't we go ahead with that? There are limitations with them. What is first? To achieve the optimal performance, we have to have a trained handler. So always a team of handlers should be with them if you want to do any detective and all, any detection. So team of handler is one. Another, the dogs also have the behavioral variation. Sometimes what happen in the difficult situation, their mood changes, and instead of sensing, they will do something else or something like that. So it is very difficult to put in the quantifiable way, that dog, we cannot rely. And the very important thing is, after every 30 to 120 minutes, they get tired. Now suppose you are going with the canis, dogs, and you are going to check whether this place has the explosive or not, and you are doing it, and VIP place, almost you are done, and you are close to the place where the actually explosive might be there, and dog will tires and he sits. Okay, now what you do? You have to run for your life. You can't do anything. So can we rely on such thing? Obviously no. And that makes me to feel no, we have to do something with our knowledge. Can we make something called electronics? No. So that is the motivation I'm saying. At very difficult place we have to go, and then we cannot do. At every time we cannot have the handlers. And if it is there and then they say smell, and they say no, I'm not able to smell, you have to run for this one. This all gives the motivation for my electronic nose. But when you are talking about any sensors, you have to know that sensor has two important properties called selectivity and sensitivity. So now, like in our case now here, there is a mic on, and how sensitive it is. Okay, though intentionally it was not turned on by somebody, but what happened? It makes me feel, or you feel, oh, I'm getting annoyed, though it was not intentionally. But it should be like the sensitivity. But at the same time, what is important here? Now let's see, selectivity and sensitivity. These are the very important criteria. I put in the form of picture, which makes easy understanding, or it goes directly in my mind. Selectivity. Assume your child is playing, okay, and it has so many toys. What happens? The child will selectively will take only one which is liked by him or her. So that selectivity, what is needed? Why it is needed? To avoid false positive. What does mean? Look at that. This is a cat, but in mirror it is looking like a lion. I gave the example, like when you are sitting in the let us say movie theater, and that false alarm goes. So the bomb is not there, is declared. So this is very dangerous. Selectivity is very important. If it is not, if you are not able to detect, no problem. But false detection is, it can put us behind the bar in terms of explosive. Okay, so that to be avoided, and it should be having a very high sensitivity. You can look at the sensitivity of this child. He doesn't have any problem, but only looking at the child is crying, he starts crying. This is called high sensitivity. And what for it is used? Why it is needed? It is to avoid false negative. Look at the very smart man, but it looks like a chimpanzee or gorilla. I don't know what is that. Means though bomb is there, you say bomb is not there. Here bomb is not there, you are saying bomb is there. Both the conditions are dangerous, and any sensor should have that. And for that, there is a very good way to overcome that is you can use the array based approach to improve, and therefore the MEMS will be playing a very critical role in that. Look at the picture of array based when you are talking about. Look at this very innocent child. Every picture has a different expression. Okay, means the your sensor basic construction is same. Okay, only thing it is behaving differently for different, and when I collect all of them, all characteristics, and I use some mathematics, I use some mechanism by which I will always get a unique output, and that is the beauty of array-based approach. It gives the sensitivity to the wider range of analytes. Analytes means whatever you are trying to sense.
Sir,
Pardon?
Sir, Ravishankar sir, that the hide caption, please remove it, sir, in PPT.
I didn't get, sir.
Hide caption. Stop sharing. Hide caption is there, sir.
Okay. Yeah.
Thank you.
Sorry.
Thank you so
Yeah.
much.
I thought it's not seen to you, so I kept it. Oh, thank you for telling me. Good. So it is sensitivity to be better on the wider range of analytes. You need to add array. You want better selectivity, as I told, you need to go for array approach. If you want multi-component analysis, which will give me various component which is taken as the features and used for detecting and analyzing, it is useful. So it is not only recognizing the analytes means explosive, but it also tell which explosive. Is it RDX or TNT or any other? Means array-based approach can not only recognize but also will give the detection also. I mean, not only detection, it also give you a perfect analysis. So sensor array-based approach is used, and that is very effectively can be done using our MEMS. So why the nose-based approach? Because the dog still says, I still smell better than we, and our ego doesn't allow that. Hey, how can you dominate on us? We are very technology oriented, we tech savvy people, we always can do better than this. And yes, and therefore we understand that what is the basic this thing in electronic nose and mammalian nose. The difference is simply what they do first snip, then they have the receptor binding in their mind, that is called olfactory receptor in their mind. Then there is a collection, these dogs or something, what they will do, they will have some smell already stored, they will compare with that, identify, and then action or something. And same can be used in electronic nose. Yes, same is used in electronic nose. So what are the various electronic noses? Explosive, some of them I have listed here. There is something called amplifying chromophore quenching, something called optical fiber and buds, something polymeric thin film, gold nanocluster, saw base, surface acoustic wave, and MEMS. All of you know MEMS. So some of them very briefly, suppose I am looking for the polymeric amplification in this, and this is very widely used, so I put this slide, nothing like that. So if you have, let us say, some monomers like that in something, though I am using chemistry words, so please bear with me for some of the time, and this analyte will come in contact with some of them. So if it comes in contact with that, only this will get enlightened, all are still dark. So what will happen? Here only quenching happens, sorry, this all are having light and this is dark. So all this will be from this to this, the change will be only, let us say, 25%. But if you connect in a series and any one get fused, so all will be quenched. So that is a simple mechanism they are using in the polymer chain. So your sensitivity becomes a very strong. There is another way they can do it also. We have the LED source and the glass substrate, and this we have the coating, selective coating. So from here we are passing the sample. Out of the sample, whatever is the trace material of explosive will come in contact with that, and because of that, what happens? This particular part will be either having more fluorescence or less fluorescence, and that is detected by photomultiplier tube. You can see here this kind of thing. So this is initially it is fluorescing very properly, means having a good light, and when it comes in contact with the any TNT or RDX kind of thing, it quenches, means its fluorescence decreases. So that is one mechanism. But we are looking for our micro sensor which are based on the micro cantilevers. Okay, So micro cantilever, all of you by this time you know cantilever is a mechanism which having one end fixed and other end is variable, and variable in the sense is moving, and this is a very is provide a very high sensitivity. With this we can make a very small and portable devices. We can have a very specific for one or other explosive, and use of array like this. You can see multiple cantilever 1 2 3 4 5, and every cantilever can be coated with the different receptive material, and that will give the different characteristics which can improve your sensitivity and selectivity, and of course it is a low cost thing. So when I'm talking about the MEMS base, all of you know it is a integration of many mechanical elements, sensors, actuator and electronics in common on the common substrate. There is a lab on chip concept also can be taken from this MEMS based approach. Okay, so here your cantilever based sensors which are very small in dimension, and it can be used in the sensor, different sensor array can be used for sensing the device explosives. So this is one of the methods used for explosive detection. Here there is a cantilever, and cantilever has inbuilt piezo-resistive heater. There is a light source through mirror amplification and directed, and the light source here, it is always on the surface of the cantilever. And what happens when the cantilever is used for the sensing and there is a vapor of TNT somewhere, you feel like this could be there. So here during the sampling, what we do, the molecules of the explosive vapor absorb on the cantilever because we have coated with some of the absorbing material, so it get absorbed on that, and because of the absorption the mass of the cantilever will slightly increase, which will be very less increase. Okay, so what we do, we heat, we provide the heat by this piezoelectric resistance. Here the heat will be provided. Due to heat, the stress which was here will get released, and because of that release, what happens, there will be a large sudden deflection on the cantilever. So that deflection is measured by this mechanism, and you can see its resonance frequency changing. So before loading, after loading. Before loading, you can see its resonance frequency is high, and after loading means loading with that explosive whatever is there, the frequency will be low. And when you give heat, when you heat it, these all molecules which alcohol absorbs on the surface get released, and again you get the back frequency. So change in frequency is used to detect that kind of explosive, and it is very sensitive mechanism which is based on the cantilever, one of them. But technology allows us another concept is called canti-FET. Some of you might be knowing cantilever with the FET. FET is called field effect transistor. Some of you do not know, no problem, but it gives an added advantage. So first, cantilever, many lectures you heard about, but FET probably some of you might not be knowing. So you can see that at the tip of the cantilever, you can design a transistor, you can fabricate a transistor, and that gives a very good selectivity and sensitivity advantage. So just to take you through that OFET, which is called organic field effect transistor, I will take you through some basic steps. So how it is done, basically a silicon substrate is taken. All of you know by this time what is silicon substrate, because yesterday I was hearing your one of the talks which was given from the IIT Bombay art facilities, which where I worked in that IIT Bombay. These are all results of that IIT Bombay when I worked for my PhD work. Okay, so here silicon vapor is taken. Then we do the dry oxidation. You heard about the dry and wet oxidation. Dry oxidation, a good quality oxide. So oxide layer are there, and then I use photolithography concept. If you know photolithography, what is that we do? We create a mask, we put on the substrate. Before that, we coat with the two type of resist, photoresist, positive photoresist and negative photoresist. I remember yesterday some of you were asking the question, what is that negative, positive? But anyway, because some of the times we want to know, we want to use mask in a way like whatever portion is exposed, that portion becomes soft and I want to remove it. But in some cases, I want the portion which is exposed to UV light should remain hard, so that other portion comes out. So it depends upon which technology, laptop technology, or the you are using the what is called the other technology, where the solutions are used to remove the unwanted this one. So Here I have used the laptop. You can see PPR I have coated, then I took the mask, then exposed to UV light, and the portion I did not want is removed. Okay, this is the pattern I wanted to have. This is for the MOSFET. The other steps for them we used here. After that we did metal evaporation. I think the 2 ways metal evaporation is done. It is called metal evaporation, or is also another method used for depositing of the metal. So I use one of them. So for making the contact here, there are 2 contacts I made, which will be called a drain and source, and backside oxide which was there, I'll remove that. So basically when I get this space here, I will coat with the polymer which act as my sensory layer. So this is a simple fabrication of organic field effect transistor. They were looking like this, my images I had taken. So here these are used as a sensing mechanism. Why I'm trying to tell you that, because this adds the beauty to the cantilever, and when we go for the cantifet we get a better sensitivity and all. So this is how my organic field effect transistor was looking like. This is a drain and source material, and the back gate is there, and then here polymer is coated which is acting as a sensory layer. And there is the R&D here. It cannot be any polymer. There where my PhD work was there to identify this polymer composite, proper polymer composite, which is really useful for sensing explosives. Okay, so this is how the mechanism, some of the things, these are all array of the sensors were used. There is some mechanism, and then output is seen directly on the PC. So there was the mechanism. You can see there is a the heater where I'll put my RDX and TNT. Actually we were using that, and which was heated, and there are sensors kept here. This is a preliminary experiment. This is advanced level experiment. I was not allowed to take the photo of that. I did not take that one. But here, and there is a electronic circuit which has many sensors. I was using 8 sensors simultaneously. You can see 8 lines here. So readings of all 8 were taken together. So how they look like. Now this is important to see. Look at here. Some of you are aware about the transistor. If you do not aware, don't worry. Don't get into detail. Only see that this is a device which has certain characteristics. So the blue color here is before exposing to that particular analyte. So there is something conduction, there is some current is shown. You can see the current on y-axis and voltage on x-axis. So this is called current versus voltage characteristics of the MOSFET or any organic field. So here you can see there are very less current values. But when I expose to some vapors of TNT and which are generated and pass through that chamber where my devices are kept, you can see there is a huge change. I was very happy. That week was the happy week when I saw such a great change in that one. That was turning point of my PhD when we did that. So here it is an explosive, the TNT, very high this one. When I checked with the RDX, it was, but it is slightly lesser because of course everything will not be there. Then I'll think about, can I look at the another explosive which are less strong. So DNB, dinitrobenzene, was also explosive, but it is not that very stronger. It is on the very lower side, though there was less. But as I said, your device should be such that in any of the contaminated place also it should be able to identify. So I look at the water vapor, what it does with that, because many of the things they will have the water molecules, and if for water molecule also if it is giving a positive response, then your sensors will be bad. But fortunately, of course, fortunately, why I'm saying, because the results were fortunate, but for that lot of study to identify which composition and all, water vapor, it is showing the negative response. You look at that, blue is before exposure, red is after exposure. So it was decreasing. In other case, it was increasing, and that was a beauty, because if you give the negative side for this water vapor, means it is rejecting water vapors, and that was really good. Okay. Similarly, the other type of characteristics I have done, and then you did not worry about, don't go into that, but there is a change. You can see for TNT always the change is higher, for RDX change is slightly low, DNB very small change, and water vapors it is opposite. So collected so many experiments, and then we look at that, we use so many polymers, composite. So response to TNT was always seen to be higher, the change in on current of that device, and response to DXC was that, and response to water vapor was negative. Okay, that was the beauty of this. And that we have used. Now I have used 1, 2, 3, 4, 5 composite, and see the composite all. In some of the composites you are getting very good response for this, and some of the composite less, but for all of them we are getting a negative, and that selectivity was very well addressed in that. And for that we need to do something. When you are looking for something, we have to use some mathematical thing, and then we use principal component analysis here for the recognition of this. So here, if also you can see RDS and TNT, you have the eigenvectors. You might have studied sometime we called matrices. So what we do, we take the all information, all these results and all this, and feed it to that principal component analysis, and the output will give you a separation of this TNT, RDX, and respond to that. So there was a response. I have taken 4 parameters of the transistor, and what was that? One was on current of the device, another is called off current of the device, third is called transconductance, and fourth is on to off ratio, very important. And all cases you can see very properly differentiating RDS, TNT with other. This is only I am talking about OFED. And look, think about the beauty. This OFED is sitting on the tip of your cantilever, which is called cantifed. How beautiful it will be. Yes, it is, but it is at the same time, it has a lot of difficult fabrication and coating that. Specifically, all cantilevers coating with the different. Yes, of course, challenges are there. Whenever there are challenges, accept them, because when you accept and you fight with the challenge, there is an opportunity behind that. So if you are afraid of the challenges, if you cannot face the challenges, we cannot go and get the opportunity. So yes, that we learn during this process of research is that only very important thing is we learn that only. Yeah, whenever challenges are there, in fact, when the more challenges, when you are very deep into challenge, you should feel like, oh, this is the time my research start. When the problem you are trying to define the research problem anywhere, or you want to do work on that, and you identify the problem in very simple way and in very easily in 1 week time or something, you should always understand this is will be a very weak research. Because when you understood the problem through the literature review and the very less literature review, it is basically, it is already addressed somewhere else in the world. So it is a very, very difficult or very simple research problem, very difficult to go ahead in that, because after some months of study, maybe 5 months, 6 months, you come up with the bottleneck. Oh, no more to be done, because already things are done. So therefore, intense literature review till you get confused, and when you do not find any path, so much confusion what to do, there where the problem definition comes. Anyway, so learning, this is all our learning. Research is the learning phase. So here you can see there are 4 parameters used. Why? Because more the number of parameters. You remember the picture, why I have shown the picture of that small child with the small different emotions? Because more the variation in the characteristics, more better selectivity you are entitled to get, more better false positive you can stop it, where very better way you can do it. You can always say no, this is there means there, and that is called multi-component analysis, which is very important, and this MEMS make us do that very easily. So when you look at that, when I have used the PCA and I plotted there, we have taken two component at time. When I have taken on percentage of on current and percentage of transconductance, you can see the difference here. The red color here for is TNT, if you can see properly, otherwise I will help you. This red colors are for TNT, this pink color is for the RDX, and all other things are together here, all other colors, but they are all non-explosive. So happy that we are able to separate explosive from non-explosive, and that too you can see separately. TNT is going somewhere else, RDS is going, means not only explosive and non-explosive you are able to differentiate, but also among the explosive you are able to differentiate. So this principal component analysis, it is called pattern recognition. Anywhere we are using multiple parameters for this classifying that, and we use some of the techniques. This is one of the technique. There is something called artificial neural network. There is called CNN. There are mechanism, neural networks, and other. I use principal component analysis, but not necessarily that only. There are various pattern recognition technique, which is a part of your electronic nose, because when you sense it, you got the parameters, but now you have to get the unique characteristics of that particular sensing analyte, and you have to say that this is the only one present. That is what I say selectivity. So when you talk about that, yes, you can get, and uniqueness is what required. You can see all components I have taken them all together. There also a beautiful thing came out, and therefore this was one of the you can say breakdown in the research study. But this is with the help of organic field effect transistor. So here you can see separately on the bigger for you, I have made it big picture for me also. So this is a TNT as a red color, pink color, RDX, and all non-explosive, whatever are there, because unless until you selectivity show, your any sensing output or sensor output or any result publication will not be accepted. My first paper was rejected badly, though I got very good result. You know why? Because I was just showing explosive can be sensed, but non-explosive are rejected, not able to show, because experiments were not done. Then after that critics, the paper rejected, only 3 lines were written. I was very upset, but I read the 3 line after 3 days, and then I understood, oh, what they are talking about, selectivity. How can I do? Then start searching for the paper. Then I understood, oh, these are also nitro compound, nitrobenzene, dinitrobenzene. Okay, these are also nitro compound, and these are also nitro compound, but they are non-explosive kind of thing. These are explosive kind of thing. So why not I do the experiment on them? And the beauty of that means with all study we could do separate of that. So this is on the organic field effect transistor. So why not we can use them on the cantilever tip, and that is called cantifet. So fabrication of organic field effect transistor at the tip of the cantilever is called cantifet, and that gives a very good result, very good sense of doing that one. So up to this, I just take you through what are the things to be done, how the sensing of explosive done with the different mechanism, and where the cantilever. So there are some examples here for you we shown. Look at that. There are sensors array, and not only sensing array, it is basically a lab on chip kind of concept, where vapor generation also there, vapor are passed, pre-concentrators also there, inbuilt heaters also there, and sensing is also there. Not only sensing, you have the electronics, which after sensing you got various parameters, they are stored. As I told you, multi-component analysis. So all component, all sensing, every single sense, as I told here, will have various parameters to study. Look at that one. Okay, in this case, not only the change in current, but the slope of this characteristics you can see is also changing. Not only that, initial part, if I zoom this one, there is a change in the off current also before explosive and after that. So here also you can see the change in the off current. Off current means when the device is off. Off means below certain current, and before exposing to that analyte, that is explosive or non-explosive, and after this one, what is the change? So everything to be observed. So the slope of this curve will give me transconductance. Those who do not know transconductance, basically it is change in current with change in voltage. That is called transconductance. On current means when the device is turned on and the current which I observe, that is called on current. Off current will be the current which is the device when it is in off state, but still when I expose to vapor, there is a change in off current also. Off current become very high or very low. That also one mechanism. And the one of them was ratio of on to off current, which is a very important. Let us say I consider my mobile. Now, the moment I touched it, the screen turned on, or otherwise it was off. So what happens? There are MEMS sensors used here. I think you know gyroscope and other. They are used in mobiles. Okay. So what is on the moment I touch, that those devices turn on. Otherwise they are sitting off. So in the power down technique, power down mode. Otherwise it consumes power. Earlier mobiles, they used to consume power continuously, and because of that the battery get drained, even though there were no many applications were there. Okay, in the mobile. Nowadays we have infinite application in mobile, and we are looking for the better and better batteries. But better and better battery is not important. Important is how we can reduce the power consumption. So here also, when we talk about any device which is sensing, on to off ratio means on current to off current ratio should be as high as possible. In fact, R&D is happening only in optimizing on off to I-off ratio, and with that only you can do the PhD. You can have some devices which are sensing in that, and you can take about ratio of this can be talked about. Another thing is when about cantilevers, when we talk about fabrication of the cantilever is very, very crucial. And in the fabrication of cantilever, you know, during fabrication there is a stress developed and the cantilever get bent, which is not a part of this my scope of this, but I'm just telling you. So there are studies on that itself, means how we can reduce whatever the curling effect of the cantilever while fabrication also was stress developed. So what I should do to make that thing? So there is a R&D on that. R&D is also on how I can have the specific coating on the cantilever. You just think about the cantilever in the micro and nano level, and you are thinking about coating. Is it coating very simple, like coating on our nail paint and having different shade? Of course no. So there is a very different way to do it. Mechanisms are there. So learning of those mechanisms, optimization of those mechanism is also one of the R&D component. Mechanical engineers always can look at how I can do various fabrication techniques I can learn, and I can do advancement in that after learning the MEMS. So MEMS means not only cantilevers, it is also there are various structures, like capacitive structure is a very important structure in the MEMS. I am coming to that part in the next. So here there are different already in use. So here you can always have in the MEMS, we can have with the various technology, we can have the reservoirs. Here you can see the this reservoir. So there are multiple sensor here. Whatever analytes we want to pass it, it will go through all of this chamber. Then it will have a kind of pre-concentrator design there. Okay, some of the ways it is how much pressure to be given an hour. So there are pressure sensors also that made up of this MEMS design. That all are integrated here. So it is, you can see sensor is there, and with that all electronics also embedded, and it a handheld device like this mobile. So I can take it in my pocket, and always I come to know, oh, here there is a danger, I cannot go. You heard about TNT, trinitrotoluene. This is used for landmines, and during world wars across the countries, border of the countries, they bury the landmines, and when the landmines are buried, you cannot go and stress them. Now many countries are facing the problem where they buried the landmine, they are not able to identify, and when they go to check there, the moment there is a load on the landmines, it blows. So they found like it's checking very difficult. So here our MEMS based electronic noses are really helpful. Going to that remote place, that there is a drone in which we fit this kind of explosive sensors on the drone, and the drone will be passed over this, and for multiple times it will sample, pre-concentrate and identify, and wherever there is a any stress detected or any vapor detection, that specific area is considered as the dangerous zone, and then that way they treated. So technology making us our life easy to go ahead and help in that, but at the same time miniaturization of that and selective sensitivity, this is only not only but it is best way possible with the MEMS. There is an advanced version of the MEMS also, it's called NEMS. I should be knowing, nano electromechanical system, which is also taking a very good shape, already taken a lot of things, but MEMS also because there are certain limitation of that names. So this kind of structure also there, these are called capacitive structure, which is used with the basic electronics for sensing. So here what are the sensing films are here, and these are called interdigitated electrodes. So capacitor, all of you should know, if you know, there are two parallel plates, okay, one plate and two plate between them. You can have any medium, dielectric medium or any medium which can be used for absorbing some material from the vapor, and the property of that can change, dielectric property can change, or the distance between the plate. If you know, capacitance formula is epsilon A by D. Epsilon is called permittivity, A is the area of cross section, D is the distance between the plate. So we are not moving physically distance, but the molecules which we are trying to sense, it goes and react between the capacitor plates, MEMS capacitor plates, which is in the nano or micro level, and at that level the change in property is observed. So that is also, it's not only cantilever, it's a capacitor structure also. One of the another structure is called SAW, surface acoustic wave. So we make the cantilever structure, and the property of the surface changes when it comes in contact with such of the analytes or this kind of explosive or non-explosive, and that property change could be a change in resistance, could be change in conductance, or could be change in any surface property which are observed. So these are all some more MEMS sensors. So this is what I'm talking about, MEMS comb capacitive sensor. look at that. These are the MEMS base. Now every interdigited this line is a plate of the capacitor. So capacitor is like that, as I told, one plate here, another plate here. So this is a capacitor in which you have some molecules which you are using as a receptor, because any molecule of explosive not going to go and sit there. So as I told in the beginning, chemistry plays the important role now. So we have some of the composites here. Those composites will be in the micro there, here this space. Okay, where you correlate this with this kind of thing. So in the SEM picture it will look like that, and when we take the more zoomed picture it will be. So in this space you are having these molecules, means this is coated with that. When it comes in contact with all this kind of explosive or anything which we are trying to sense, here you look at that, surface modification takes place. First, to attach this molecule you have to modify the surface, you have to do, that is called functionalization of the surface, and that molecule can be attached. Now this molecule have the capacity to attach NO2 or any of this which you want to sense. So when you do that, there will be change in the distance. Earlier the capacitor plate distance is between this plate to this plate. Now you can see there is a additional layer because of the molecules which were there, you got them attached here, and then when you are sensing, that will increase. So actual distance, virtual distance is decreasing, and I saw capacitor formula epsilon A by D. So distance between the plate changing, capacitance changes, and that is a way capacitive sensors work. And not only that, dielectric property, because capacitance between two plates is also a direct is directly proportional to dielectric, that is the medium between them, and the medium property itself also changes. That also gives us the change in the capacitance, and that change in capacitance can be directly correlated or can be calibrated to get how much change we observed, and how much explosive or any other we are sensing. So it is not MEMS based sensors are not only used in explosive, they are used in the nerve base, nerve gas detector, gas leakage, on electronic noses. This is a wrong question to ask, but I will ask, and I will not wait for the answer. Do you have the fridge at home? Of course we have the fridge at home. Okay, have you heard about the BioFresh some advertisement? Yes sir, something we heard about. What is basically, suppose I have the fridge. In fridge I am keeping some apples or some fruit or any vegetables. What happens, every 2 or 3 minutes or 2 or 3 hours or every 2 or 3 days we go and check apple is in a good condition and all, we smell and all. But this is at home you can do. Think about cold storage, and in place UAE where I am here right now, Dubai, big cold storage are there, because so many things which we get across the months and then they are not available every time, so we have to store them in the cold storage, and big storage are there in the supermarket, hypermarket. So when they are storing there, and is it possible that every time men go and there and we will smell that mango and the apple and find, oh, it's bad or good? It's not possible. So what we do there, we have embedded micro MEMS based sensors there as an electronic nose or something. Okay, so electronic nose, what it does, it always keep on collecting the vapors of that, and those electronic noses are already trained for what? For getting the good quality. So they know good vapors for the apple, they are already stored, and then when they sense, they all compare. Then our electronic circuit based on that, all electronic nose which will have, it will always compare these properties what we are getting from now sensing and earlier sensing, good property already stored, and also bad property of the those fruits and everything also will be stored. So when you get this new vapor, then it will be compared with that, and whenever we find a close to that it is going towards the bad, immediately these people, what they will do, they will put the sell. Oh, this weekend we have the apples, instead of 300 kg per 300 rupees per kg, now it is sold in 150 or 100. We all jump and we buy all those things. Actually they have to throw that one, we are buying those all these things, so they are very happy. See, people bad, very bad sense of understanding, and then they are taking all the things. Sorry to say that, but it's the fact. But anyway, those kind of things are possible with this. Okay, not only explosive, but you can do for this kind of thing. And this electronic nose for alcohol detection. You see a very bad thing. Earlier I used to see our policemen, they are smelling, they're close to come close to my mouth and they will smell. Very bad duty they were doing, but thank God to electronic noses. Now they can have the electronic noses based on this, and MEMS made this thing easy handle thing. Okay, therefore the MEMS and explosive or any other, it plays very important role. So see the size of that. This is 1 rupee coin or $1 coin, whatever is there. So this is the shape of electronics which is possible. In fact, now we have even smaller than that. So you can see that there is a carrier gas pass through that with the nitrogen to the experiment. So this is the response, and when nitrogen with the TNT, because TNT cannot be taking alone, so it has to take with some of the inert gases which will not have its own effect, but only TNT. So there is a change. So this delta N, the change in that is observed as a sensing this one. So some of the researchers are going in a very big level. This is 16 channel electronic nose. 16 channel. Okay, you just say okay that there are 16 such cantilevers or such MEMS bits. This thing are there, and all are coated with the different selective material. And see the beauty of that. What will happen? All will have the different characteristics. Again, remember the picture which I shown with the child with the different this smile. That you should always remember. Oh, sir, when we are talking about the multiple array, we have the added beauty of we get different characteristics of that. And when we do some mathematics on that, I will get a unique output. And then yes, look at that, the electronics they have done. It is called FPGA, which is called field programmable gate array. Means this can be programmed for doing calculations what we want to do, because as you know, you have to store good samples in some location, then you have to sense the new samples, compare with them, do some analysis on that, which I told principal component analysis or any other thing. This is done through all this electronics, vapor detection, this kind of lab on chip concept, everything, and doing the experiment. This is the setup of their lab computer. What they see that. So first, all electronics is done with the simulation techniques. It's not like directly you go and do the fabrication. Of course, no. All electronics are done with the fabrication. Electronics I'm talking about because I'm from the electronic background, but mechanical people and all, you do all MEMS simulation. There are with different simulators. So first, all things are simulated, checked for that condition, and then they are. So this is, you can see a complete flow of that. There is a flow they make with all needed thing. Whatever material that they take, you have to go through that high frequency channel, low frequency, whatever is there, whatever we need to do. This is called analog to digital converter. Everything are used here. This is, and if such kind of analyzed pass, will we get the output or not? So they first do the simulation. Once it is done, then for that electronics is made, and then this kind of prototype is made. Here you can see that the last component is TNT. Sorry, it is very small letter, but yes, I'm saying this green one is the TNT, and other two are the empty chamber. To see that, first empty chamber will be passing because we need to have some basic offset to be known, and then TNT, because this is vapor to be generated, because TNT is in the form of stress, no vapor. So vapor to be generated for making that. So there is a mechanism they make for making TNT vapor generated, which are given to the input of this circuit, which is having the various 16 channel this one, and they are checked. And this is the sensors already in use. Okay, this recent publication 2017, and they published the advanced one in 2019. So there are various places the electronic nose is in use, which is making the life easy. R&D is continuing to be there, and it is happening. It is making, so there is a good scope of doing a very good R&D in that. This talk was around the application side, not on the fabrication, because already I requested Dr. Kiran to give me the slot towards the end, because earlier by that time you will be knowing some of the fabrication techniques or something about, at least ABCD about that. But still I tried to make this talk in a way like you should not have very technical requirement, but also you understand. So when you are talking about the some places and application at works, so like, look at that, a very small, as I said, TNT. Can you go with your vehicle there and do that? Of course you cannot do. So there are places where you cannot go. So we have the nano robots, okay, like a bomb detector or rescue robots. They are very small. Okay, I will tell you the dimension of that. Very small. So here your electronic nose is there. So it will be remotely, it will be sent at that location. Okay, that will go. And whenever it finds, there is a drone also, but this is also option. In some cases where this cannot go, the drones will go. but depends upon the technology availability and then accessibility of that place, everything. Some of the time it is hidden below the bridge and everything, how he can go there, so their drone will go. Technology allows us, it allows us to do so many things. So it is small level, you can see in a very small level your complete electronics is fitted. Battery backup is here, so everything is in the small level, and that can be used for, I said, in the beverage, in the food product, this all MEMS are used. Environmental monitoring are very important nowadays. In every new building there is something called building management system, where we are trying to sense everything in the sense, is there any smoke, is there any no gas, is the oxygen quality proper, is the oxygen level is everything, is the carbon monoxide level increased. In this, everywhere we want, everything should be known to us, and that they sense, and then in the control room our sensing parameters are seen, our automation is done, and then automatically it tells if the level is above, below or something. Accordingly corrective actions are taken. Sometime what happen, a big building where the gas pipes are there, mainly in our UAE Sharjah here, what happens, the gas pipes are there in the bigger very big buildings, and anywhere the gas leakage or something is there, and if suppose it catches fire, whole building is directly under this one. So in this kind of sensors we are doing one design now. What is that? The moment every flat will have this small sensor embedded, and the moment anywhere the gas leakage is or anything found, our system will take care that this is detected, and automatically it will go. I know there is 9 minutes left, so I will not take much of the time. So every that detection, and it will go to the system where my input of my building, where the gas pipe is going on. So there is a solenoid valves or something which will be controlled by my mechanism. So wall will automatically close. So every building's the gas flow will be stopped, and there will be alarm or something. There is a SMS going to the security as well as another management people. They will look into, oh, there is something leakage, and also it will identify which floor, which flat the leakage are somewhere which is there. They will go there, check it there. Once they clarify everything, then and then the gas will be, pipeline will be turned on manually. So these are the things which always we can look at the application. As I told, mobile robots. Look at the mobile robots. What is the dimension I'm talking about? So small. So this is the petri dish in which the mobiles are kept. So this kind of things are very much are in use. You can see they are going into the field with the flag, and then it's looking that, oh, there is a landmine or something, or somewhere the hidden explosives are there. So it will take care of that. Instead of having dog, you can have such kind of thing. You can see, you can make a very big layer of that, multi-layer PCB, everything, means complete electronics on chip. MEMS make this possible. Not only possible, it is already in use. Okay, so there is nothing impossible right now, because as impossible always says, I am possible, and this made our journey, our this thing very useful. And so for you, it is a very good scope to go ahead and start learning, start reading others literature, start getting what they have done, understanding that, then what are the research gaps, what else we can do, identifying that, and start working on that. So with this I will conclude my session. And why this was there, electronic noise, and now you can understand that there is a bomb kept. Okay, and then cannies are used, and they are saying, oh, sorry, we don't smell this like a bomb, because they are not in good mood that time. Their mood is different, and what is there, you have to run for your life. You can't do anything, because once the bomb explodes, it will cover at least 1 kilometer distance, so you can't do anything. Therefore the necessity of this kind of electronic noise, explosive detection, everything comes into picture. And our MEMS, what is the MEMS definition? All of you know, my engineering, my solution. So start doing engineering and start getting your own solution. So thank you very much for patience listening, and it's over to you, Kiran sir, and all.
Okay, thank you very much, sir, for nice motivating thoughts initially, and then nicely covering all the aspects of the explosive detection. Now we will take some questions, sir, here from the
Yes, sure.
audience if there. Yeah, there is one question from Suresh Kumar, Professor Suresh Kumar. What are the future directions of works in explosive detection using MEMS?
Pardon, can you repeat the question?
It is in chat box, you can refer to. What are
Okay,
the
one minute.
future directions?
Yeah, future direction in the explosive detection. Now, as I told, one is how we can improve the sensitivity, because the concealment of the this all explosives are so properly done by these people. then getting that vapor, right now we are able to detect up to parts per billion and parts per trillion. Now we have to see that how we can make better sensors, means sensitivity can be improved. So one is that's getting chemical composites. So some of the researchers are going in getting the selectivity, means only not sensitivity, but I should be able to select only that particular molecule. So what they are doing the reverse engineering kind of things, the polymer which are designed are in a way that they are the first molecule of TNT will be embedded with the polymer, and that polymer will that molecule will be taken out. So when that kind of molecule comes, that only fit. For us mechanical electrical engineers, the design in the electronic noses, so concept of electronic nose to be understood, and how we can you make better electronic noses for that. So understanding electronic nose, understanding the fabrication challenges, how we can fabricate many number of cantilevers or many capacitor structure at the micro level, and another is how we can specifically coat that. So that kind of thing, and the research is going on, and we are trying to optimize that. Another is sensing time. We cannot afford to sense late. So sensing time optimization, these are the three very important criteria, and of course the cost effectiveness. These are the 4 places the R&D is going on now.
Thank you, sir. Any other questions from participants? Any other questions from participants? Please feel free to ask.
When the questions are not there, there are 2 things. Either understood everything or not understood anything. Understood everything is not possible. Not understood could be possible, or some of the time it's okay, later on we'll study and we'll come to that. So I take it positively all the time.
Good morning, sir.
Yeah, please go ahead, sir. Professor Madhava Reddy, please go ahead.
Yeah, the specific software for MEMS analysis, yes, there are software like for mechanical. ANSYS is the software. Then another software is called console multiphysics. Okay, multiphysics, because this involved a lot of analysis of multiphysics component, because as you see, the any change, anything, the flow of your explosive, if you are detecting in the liquid flow, so you should know the flow analysis of that. We should know the pressure of that. We should know the temperature analysis of that. So all physical parameters. So all multiphysics software, like as I said, ANSYS is one, console is another. There, yes, modeling is very important. Another question I can see, the modeling very important, because when you are looking for the software, they will not have the specific model for us. So we have to design the model in a way like it should be able to. Suppose we are trying to do the micro cantilevers and the very small design at that. So I have to make a model which will be able to simulate. So there is a very good scope in modeling of this kind of simulation software parameters. Okay, so not making the simulation software, but modeling of that using simulation software is a very good research area going on in that, because everybody cannot do the experiment with the help of RDX and TNT and everything, but we can always do the modeling of that. Let us say I told you organic field effect transistor and cantiFET. Right now in the simulation, they are very rare to use. So they are very rarely available. So there is a R&D going on where we can always look for change in the model parameters, so that I will be able to simulate it. Unless until you do the simulation, there will not be very good output. We'll able to identify and make our life easy, our fabrications life easy. We cannot go and do fabrication now and then. First you have to do with the simulation. So major focus now is on the simulation and the modeling of that. Yes, so you are correct, modeling is very important. Which software we should study? Yeah, so which field, if you are from mechanical field, I said ANSYS and this and the console, which I feel right now they are in use very heavily, but you can use these 2 softwares. I personally propose these 2. There are many, but I personally give, because there is a lot of community across the world working on this one. Yes, console is not free. even ANSYS are not free, but they have some initial free version. This one you can try on that, because some of the things when you go for the modeling of that, limitation comes. So either, therefore, yesterday in the talk in IIT Bombay also I asked that, do we have access to this remotely for other users across they are thinking on that. So there are softwares which may not be free, but yes, initially for a month or something they make it give you free. You can start working on them, start getting in there. There are free tutorials available. You can start using them, start mimicking. And a very first thing is mimicking, in the sense, get the thing somewhere published, and using that simulation, repeat that same thing in a month time or something when you get. So when we start doing on that, you can do. And some specific question if are there, I'm always there with you through this team. They can contact me. I can tell you, those who are really keen in doing anything, I can guide you on the more part of this.
I think one more question from S. Madhava Reddy. Sir, can you post your tell the question?
Yes, sir.
Pardon?
I got answer, sir. No problem. Kiran, sir.
Oh, okay.
Okay.
Thank you, sir. Thank you so much. Right.
Any other questions?
Sir, Ravishankar, sir. Good morning, sir.
Yes, sir. Good morning.
Actually, I am Madhav Reddy from Hyderabad, sir.
Yes, sir.
So,
Welcome.
we are mechanical background, sir. But actually,
Yes.
we have
Yeah.
PG and PhD students are doing research work, and
Yeah.
related to what topics is thrust areas in MEMS, we have to guide the students, sir. Please, can you suggest?
Yeah. MEMS area of thrust. We can look at various. Let us say we are talking about the latest one, automation, electric vehicle. Okay. So electric vehicle now, very important thing is generation of the energy. Okay, and use of the energy already. So there is a braking mechanism. Okay, there braking mechanism from where I'm talking about your mechanical part. Okay, so we can have regenerative braking system. Okay, so regenerative braking is the way to generate the energy. So we can do the simulation of the regenerative mechanism by the software. That is a very important area. Another is battery management system. When we are looking for that one, okay, so battery, how the life of battery can be made more better, and that kind of simulation using that. So can we use our MEMS? They are in use. Okay, that one. Another is this one, your mechanical. When we are talking about, can we have the microfluidic structure which can be studied? Because when we are talking about the biomedical application, because I see some of the question also in biomedical field. So when I'm looking at my this heart related studies, are, you know, many patients are having a problem of liver. Okay, and then we are using a dialysis, very painful thing, very painful. And then what happens in this MEMS is coming into picture. We have in MEMS, in the dialysis part, the membrane which are used, they are able to pass some of the components from the blood, and some part they are blocking. But whatever the membranes right now they are used, when the dialysis is done, there people, they feel very energy drained, because everything from their blood is taken out, the good and bad, everything. So we are looking for optimization of the membrane, and then design of that. With that MEMS membrane, can we do some good membrane design? And that this is one of my PhD topics. Student is doing like that. So in the biomedical field, this is one of the topic where cardiac sensors using MEMS. Then there is a electromyograph, means EMG, that for my brain signals, there is the sensing of that with the MEMS. That is the mechanism. Then I want my when I go on the practice and I am doing my exercise and all signals and all with my watch and everything are any built here, which is called flexible electronics with the MEMS. Those structure flexible. These are all the research area which is coming up, and then that is in use. So nobody wants to carry a big devices, and nobody wants to go to doctor here now and then. So what we can do is we can have a MEMS based design which are already at place. Some of them, some are undergoing research. That put on my hand, and anytime any problem or anything comes, that will be notified to me, or not only it can be accelerated to my doctor or my family member, and that kind of thing people are looking for. So biomedical is a very huge application, and in that these are all fields. I feel there are application, there are this one. But as one question I can see, challenges in power MEMS. Very good, very important question. Yes, but as I said, any power related, we work on the three concept AMG. What is AMG? Avoid, minimize, and generate. So first thing, we all R&D going on, how can I avoid the more power consumption? So how I can design the low power consuming devices? How can I minimize the power consumption instead of generating? But generation only to be done if needed. So R&D on that is consider the fact where how we can minimize the use of energy, and then you look at. So some of the sensors now, they are using a small solar energy based concept also. Some solar energy can be used for that solar power backup, but major thing is how I can reduce the energy. So power backup is the problem, but it is taken care by the advanced study which we are doing, where low power devices are there. Your MEMS based now, it's working on 0.8 volt also. 0.8 volt I'm taking you. So 0.8 volt, 0.65 volt, and some of them, and very beautifully they are doing the R&D. My body energy only can I use, they are talking about. So from there also some millivolt is generated. So there are ways people are coming up with. There are challenges, and as I said, challenges are there, so opportunities also there. So kind of that both combinations is the research area. As and when we go proceed further, we have to go hand in hand. We cannot go for very cheap device and more power requirement. We cannot. We have to have low power. We have to have time response also fast. So always technology goes with the something called figure of merit, which is a combination of power and delay. Means less power, less delay, which is product of this is best. That is the best technology, and of course the cost also we have to take into. But really technology is coming up in this all field and the biomedical field and all fields. There is a very good scope of research already going on. We can also start with, and if you want, some of you, my personal ID also will be sharing with them. You always can drop. I will be happy to be with you one-to-one also.
Thank you, sir. Thank you very much for your session. So we have got so many discussions here, so that's good. Sign of a good session we had. So thank you very much, sir, for nice session, very nice informative session. Thank you very much from the SPCU team and all the participants.
It's my pleasure, and all of you have the happy researching. Okay, so whatever we have done, whatever we learn, it is, as I said, we cannot become master, but at least we are on the path, and therefore I said pandemic redefined by all of you. And thank you for all of you for redefining the pandemic. You have come out of your busy schedule or everything, and you are trying to learn something. Very good. Keep it up.
Dear participants, next session will be at 11:30 by Professor Pradeep Dixit of IIT Bombay on MEMS packaging. Be here only. Thank you.